Hello everyone, today we will solve some problems in integral calculus and we will show them in an easy way. So you will see that the problem that seem really complex can be done easily and fast. Okay, so the first problem that I want to consider is the following problem. These problems are taken from the MIT integration contest. So if you want to have more information about them, you can refer to this page or you can check in the section where I will put all information about the video. Okay, we will integrate this function, the cosine of x to the 4 minus sine of x to the 4. So of course integrating this is a little bit difficult because it has cosine at 4 minus sine at 4, and we know from trigonometric integrals that it will imply to write like products of sine and cosine. But instead of doing that directly, that it will be the hard way, we can just use some clever algebra from beginning. And from this clever algebra, we will have the following. Here this is cosine square of x plus sine square of x dx. Okay, we know already from Pythagoras identities that this is 1. We know from trigonometry that this difference is cosine of 2x by dx. Yes, this one. This is this. So the integral is equal to sine of 2x divided by 2 plus c. Okay, so it was fast. It didn't take so much time. It looks more crazy, but it's not so complicated after all. Okay, so we can continue solving another problem. So for my following problem, I will use a definite integral because I have shown mostly problems with integrals that are not the definitive integrals. So what is the problem with I will use? So this is a good problem. This is a problem is this one, integral from 1 to e of natural logarithm of x squared dx. So here we just require to use some algebra. This is natural logarithm of x by dx. We can make substitution. Remember in the video in integration by parts we explained this trick, and then we can say that u is 2 times natural logarithm of x and dv is dx. So using integration by parts, I will just integrate by parts indefinite integral, then I will use the limits of integration. This is du, this is 2 dx divided by x, and v is equal to x. So okay, this is, I will move here a little bit for having more space, so you know how does it work. So u by v, this is 2x by natural logarithm of x minus integral of b, this is b by du, this is 2 dx divided x. So reduce this with this, and this is equal to 2 times x natural logarithm of x minus 2 times the integral of dx, and this is 2x natural logarithm of x minus 2x. Okay, plus c, but we don't require at all. Now with this in mind, we can evaluate the integral that we require. I will do an arrow, kind of arrow. Then using the integration, then we only require to calculate the value in the limits of integration. This is 2 times e natural logarithm of e minus 2 by e minus 2 by 1 natural logarithm of 1 minus 2 by 1. Okay, this is 2e by 1 minus 2e minus 2 by 1 by 0 minus 2. Okay, it reduces with each other. This is equal to 0. Then the final result is that this integral is equal to 2. Okay, so as you can see, it was not a complicated problem, and it was done easily using properties of algebra. Now this one, it looks really nice. Minus integral from minus 9 to 9 of sine root cubic of x. Okay, this integral seems hard because we don't know a function which can be like the integral, or can be differentiated to give sine or root square of root cubic of x. But we know something from here. We know, so we can take like fx equal to sine or root cubic square of x. We know that f of minus x is equal to sine or root cubic root of minus x. This is equal to sine of minus cubic root of x. We know also that sine is an odd function, so this is sine of cubic root of x. So, and it's well-known property for odd functions. For odd functions, we have that integral from minus a to a. Okay, we can remove this. From minus a to a of fx by dx. Of course, f is defined in the interval from minus a to a is equal to 0. Okay, it makes sense if you make a picture what is an even function, and you see that this has value a and this has value minus a. So when you add them, they are 0. Okay, so far it makes sense. So we can deduce that this integral, let me use another color for avoiding confusion, is equal to 0. That's all. So it was easy. We didn't require to do any kind of algebra so far. Okay, so this is an interesting problem. We can find another interesting problem. Okay, I will solve this problem. Integral from minus 1 to 3 of e to the minus absolute value of x by dx. Okay, what is the problem here? Again, we don't know any function that has any elementary function that has as derivative the e minus absolute value of x. Yes, so instead of calculating this directly, we will just separate it in an interval which is composed by negative numbers from minus 1 to 0, another interval from 0 to 3 of e to the minus x by dx. And we will recall the properties of absolute value. Absolute value of a negative number is minus x, so we can separate this is minus minus dx, and the absolute value of a positive number is x. Absolute value of x, if x is a positive number, is x. Okay, so far we have minus integral of e to the x by dx, different from minus 1 to 0, plus integral from 0 to 3 of e minus x by dx. And this is equal to e to the x minus 1 to 0 minus e to the minus x to 0 to 3, and this is e to the 0 minus e to the minus 1 minus e to the minus 3 minus e to the minus 0. And we have e to the 0 is 1 minus e to the minus 1 can be reduced further. This is e to the minus 3 plus e to the minus 0. This is 0. But 1 plus 1 is 2. 2 minus 1 divided e minus 1 divided e at cube. Okay, and this is the result of this interesting integral. So as you could see, instead of attacking the function directly and trying to find a function which derivative is e to the minus absolute value of x, we separated the problem. We use properties of absolute value, and then we just solve it as a common integral. So it can be done easily. Also, I'm not sure how to find a function that fulfills this, like an integral of e to the minus absolute value of x. Maybe I can find with the same strategy, but then I have to put if x is positive or if the domain is positive or negative. So it makes it a little bit more complicated. So instead of doing that, we can just analyze the problem, separating it. Okay, another integral that for me was interesting. Okay, in this case, we are doing like short integrals that can be solved with simple tricks. But more than the length of the integrals, I want to point out the tricks that I require to solving these problems. problems. Okay, so in this case 2 to the natural logarithm of x. So if we write 2 to the natural logarithm of x, we will say this is y. And then the idea here is to write 2 as e to the natural logarithm of 2. Okay, so what is the idea here? That 2 to the natural logarithm of x is the same that e to the natural logarithm of 2 multiplied by natural logarithm of x. And we can rearrange this expression. This is e to the natural logarithm of x to the natural logarithm of 2, and e to the natural logarithm of x is x to the natural logarithm of 2. So I can integrate this function and I can obtain integral from 0 to 2 to x to the natural logarithm of 2 by dx. Okay, this is we know very well this is just the integral of plus 1 divided natural logarithm of 2 plus 1 from 0 to 2. And okay, in 2 we have 2 to natural logarithm of 2 plus 1 divided natural logarithm of 2 plus 1 minus, okay, 0 natural logarithm of 2 plus 1 divided natural logarithm of 2 plus 1, but we know this is 0 divided something, then that is not 0 and it's well defined, so it's 0. So the final answer will be like 2 natural logarithm of 2 plus 1 divided natural logarithm of 2 plus 1. Okay, so this problem is not a great deal after all. Okay, so how can we continue making more interesting problems like this? Okay, I have something in mind that we can check. I would like to calculate a more strong integral that we can find here. So what is the idea from here? Okay, I found something that I like. So what I have found is this integral from e to the 3x by arctangent of e to the x by the x. Okay, so this integral, okay, we don't know how to relate them at first, but if we just consider a substitution, we say like, okay, maybe we will use integration by parts, so avoid using u. We use w is equal to e to the x, so the w is e to the x by the x. So this, if we rearrange this expression, this is e to the 2x by arctangent of e to the x by e to the x by the x. This is equal to w squared, because w squared is e to the 2x by arctangent of w by the w. Okay, so this is, until now we could transform this from one integral which looks complicated in a simple integral that can be solved in more simple terms. So what will we do now? So we see arctangent, and we see this is an algebraic function, and we see this is an inverse function. We remember our trick for integration by parts, so we can say, okay, u is arctangent of w, and the v is w squared. So the u is the w, 1 plus w squared, and b is equal to w at the cube divided by 3. Okay, so what we will do here, we will just multiply the expressions. Let me use another color for following the procedure. So let's use this color. This is equal to u multiplied by v minus b multiplied by du. So w at cube divided by 3 arctangent of w. So far is not a problem, this is just algebra. 1 divided by 3 w at cube, 1 plus w squared dw. Okay, and as I told you before, if we want to solve this integral, we have to divide w at cube by 1 plus w squared until we get something smaller. Or instead of doing that, I can teach you this trick. What is the trick? So I have w at cube 1 plus w squared dw. So let's add something that has the following property. So if I factor the first part, then I can eliminate the denominator. So look at this, w squared plus 1 divided w squared plus 1 minus w1 plus w squared by dw. Then this eliminates with this. This is the integral of w dw minus w dw multiplied by, okay, sorry, it doesn't look so nice, multiply 1 plus w squared. Then this is w squared divided by 2 minus, okay, we can do this by memory. Remember that I told you it's important to know some integrals by memory or just by inspection. And as you can see, the integral of w dw divided by 1 plus w squared, this is 1 divided 2 of natural logarithm of 1 plus w squared. Okay, we have this integral. We can just copy this part and add with the other part that we found in the other whiteboard. And okay, we will just put everything here. So let me eliminate some things, move this. Now this is the integral of w cubed divided by 1 plus w squared. And we can put it here. Okay, let me eliminate this one. And we can move this here. Okay, it makes me more easy the work. Now we just replace, what is w? W is e to the x. I will just put here. So, and let me write, this is I, so you will refer, and I don't need to write everything again, so I can just write I is equal to e to the 3x divided by 3 by arctangent of e to the x minus, here I can make some arithmetics that can go out. This is 6 because 3 by 2, 6. W squared is e to the 2x minus natural logarithm of 1 plus e to the 2x and plus c. Okay, we have found this integral. It was not so complicated as we expected from the beginning. So for today, this is the tricks I wanted to show. But I want to show additionally one thing that can be done using kind of algebra. This is the trick that I want to show, like my final trick for today. Let's calculate this integral. Let's calculate the integral of sine of x divided by sine of x plus cosine of x. I know there is a lot of ways of doing this integral. For example, we can just put 1 divided 1 plus tangent of x. If we make some algebra, or 1 plus 1, or 1 divided by 1 plus cotangent of x, sorry. Or we can make a substitution that people used to do, like for trigonometric functions. But we will do something more simple. What I want to show you? I will show this. I will call this A1. And I will define A2 as the integral of cosine of x divided sine of x plus cosine of x by dx. Okay, so if you calculate A1 plus A2, this is the integral, so you have to add these two parts, this and this. Then this is sine of x plus cosine of x divided by sine of x plus cosine of x. Because remember, you have the same denominator, as in this case, you add the numerators. Okay, by dx, and this is equal to the integral 1 by dx, this is equal to x. We'll put plus c. Now, if I calculate a1, a2 minus a1, this is the integral of cosine of x minus sine of x divided by sine of x plus cosine of x by dx. And if you can see, this function from here is related with the function here, because this is the derivative of the top, is the derivative. So this is the natural logarithm of the absolute value of sine of x plus cosine of x plus c. I will call this c1 and c2 to avoid any problem. So I want to find a1. How can I find a1? I can take the first equation and I can subtract the second equation. Then I will get first minus second, then a1 and a1, then plus, they became 2a1, and a2 minus a2, they reduce each other. So it is x minus natural logarithm of absolute value of sine of x plus cosine of x plus c. Then e1, this is what I wanted to find, is equal to x divided by 2 minus 1 divided 2 natural logarithm of sine of x plus cosine of x plus c. Okay, this is the result, final result of our integral. So this is what I wanted to show today. Of course, you can find a2 following the same procedure, and as you can see, we have reduced this hard problem in substitutions, because it's hard if you make substitution, that is for sure. It's a lot of algebra. We have reduced this problem using some clever algebra, and we have obtained the solution of the integral proposed. So you have a set of problems that go from different branch of techniques of integration, and they require more than a hard algebra or a lot of calculations, okay, except for one that I use a small trick, but I had to use a bunch of algebra to arrive it. But in general, these problems have as common denominator that it can be solved easily using some properties or using a clever approach to them. So this is our video for today. Thank you so much. Have a good day.